Welcome to the Tech League podcast. Hello, welcome to what we are calling the Tech League podcast. Very interesting. We'll see how that goes. I'm joined as always with my co-host Krisztian Fischer.
Hello.
I'm Toby Sears. I forgot to mention that. And this week we're going to be having a bit of a more casual discussion on startup engineering. So the idea is we've been through it a few times where we've gone from nothing to companies, and there's a lot of things involved in that, like getting started with an engineering team, development team, like the build pipelines, how to choose a cloud, these kind of things, like when to start deciding on standardizing around a certain language, certain framework, stuff like this. Communication internally, how to document stuff. There's a lot of stuff involved, and I thought we could have a bit of a discussion about that because I'm involved in something like that at the moment. So for a bit of context, I'm working at a startup and we're trying to scale very quickly. We're going to go from nothing to tens of developers pretty fast and a lot of customers pretty fast. So we're being asked to design in a way that sort of supports the goal organization in the future. But that's probably not the main way that a startup engineering would go, but it's probably something we can discuss in terms of context. Mm-hmm. Other startups we've also seen, I'm working with a lot smaller one that does a lot of vibe coding. They're struggling in different ways. So they have a lot of enthusiasm, but they have a lack of organization, and it's biting them in the backside somewhat at the moment. So that's what we're going to talk about today. Thoughts? You're looking forward to it?
Yeah, we've done this a couple of times, both you and I. So we have some applicable experience here, I would say, and a lot of takeaways that we've seen along the years. What we have noticed, I would confidently say, is that there are we see the same pattern being repeated over and over again in the startups. They tend to make exactly the same mistakes, which cost them dearly later in the growth phase. So we could unpack those topics a little bit and see if we can.
So we can maybe we break this down because you can say there's probably two types of startups. There's the underfunded and there's the well-funded. But there's four types of startups. There's multiple. Okay, there's two categories. We can have two categories: underfunded in a basement or in a garage somewhere, hacking something together. Well-funded, lots of money. That doesn't mean that either of them are going to be good or bad, because well-funded startups can also be crap because they make bad decisions, and underfunded startups can be good because they make good decisions. So I think it boils down to what are the right decisions at the start to make. So from your, let's maybe start with a scenario. Krisztian, you and I are starting a new startup. We'll start from the focus of we're in a basement somewhere. We're in your Utahus. What's it called? Your Utahus. That's our little office. We've got a little office. We've got two desks. We've got a really good idea, but we've got no money. How do we go about it?
Well, I guess it depends on what we want trying to achieve. In our case, we would already have the expertise to get started. So on the human front, I think we would be covered for most of at least on that engineering side. We would need to complement ourselves with non-technical people, which is mistake number one that most technical startups do. They purely focus on the tech. And you can build the best technology ever in the world. If you can't sell it, it's worth exactly $0.
We've seen that a lot, yeah.
Yeah, so that's a very early common advice, I would say, complement the team with people who are thinking about selling the product. We have seen over and over in the industry, just think about the biggest companies, was Facebook the best social network? No, it wasn't. But they were the best at selling what they do and creating the business relationships they needed to do. So it's not only tech what you have to focus on, but on the tech side, if you're underfunded, I would just do whatever it takes to get to the customer. I wouldn't overthink it. I wouldn't care about making it scalable because you have exactly 0 customers at that point. Just get it done as soon as possible without over engineering it.
Throw the idea into Lovable or Replete, get some sort of MVP prototype up and running ASAP, and see if you can sell it.
Yeah, that's a good approach. It would be the goal at this phase is to prove that the idea works. So it makes 0 sense to work months and years on it and then try to sell it a year later and then having zero traction, right? So that's just time and money wasted. So get to the customer as soon as possible with a minimum viable product. And it doesn't matter what it looks like internally. If you architectured it properly or just throw something together, it doesn't matter at that phase.
So like I would focus on how to onboard customers and delivering the barest minimum amount of features. And I would be really laser focused on that, because something I've seen from startups is they define an MVP, right? And it's a set of features, really, and that's great. But then they start progressing and then they do another feature and another feature, and the feature creep just keeps happening. And then they go, oh, we can't release until this X feature is released. What I would do is you need some kind of flexibility, sure, but you go, if this is especially a problem if you're founding a company with a product or salesperson, is they won't understand the technical requirements of building all these features. They just think, oh, you can just throw together this. Hopefully you have a founder that trusts you and you can talk to them about it. But I would sit them down in a meeting room or on a call or something, write out, this is what we're going to make, right? And focus really on the customer side of things. So super easy onboarding. It does what your idea does and provides the value. Then you go away, you hide in your basement, you ignore them until you have delivered those features. That's what I would say. And then they can start taking it and selling it. And then you can iterate on it from there on. It's that there's this, what is it? It's like it's not the fear of failure. It's feature creep, but it's also like imposter syndrome startup style, where they feel like, oh, we're not good enough. We have to keep adding features.
Yeah, definitely. It's one of the pitfalls. So, and I'm guilty as well. What we create is like never good enough, because we are engineers at heart. So we want to make it better and better. And we see problems and we want to fix the problems. But so we have to have a very conscious decision to ignore those problems and just get something out, because having something out is much better than working forever on the perfect product that will never reach the customers. So like a short time to customer, time to first revenue, or whatever the metric is that you want to achieve, is important. Like to keep it short, iterate quickly. I think that's the
thing. Like deliver the first version ASAP, get it out, and then iterate from there, pivot from there, whatever. It doesn't matter as long as you have something out and get over that, because it seems like a big hurdle for a lot of people to deliver that first version. And once you're over that hurdle, then you can pivot and change and stuff.
Also, it's a mental barrier to put out something that you know is not perfect. It's very hard for an engineer. So I think the theme should be, you should release it if it's good enough, not when it's perfect.
Yeah, perfect is the enemy of good, as they say. But I would be like, I was thinking it's similar to maybe like authors or musicians and stuff. But the benefit of our industry is that you can change it after it's out. Like if you're an author, you can write a book, and the first draft is going to be pretty bad, probably. And then you iterate internally, and then you have this deadline. And it's like legacy software is like that as well. Like when you had to ship a CD to the end client, it had to be good. But now with the internet and SaaSes and websites and whatever, like it's super easy to push updates all the time. So just get something out and go. Unless your startup is the final product, sits on a disk and then gets shipped. And then you have to do QA and everything internally and make sure it works.
Yeah, we typically talking about software engineering here. So it's in our industry, we have the luxury of releasing updates later.
But okay, so that's the main pitfall I see with startups who are underfunded. Then the other side of the stuff is well-funded startups who have already proven the market fit and they need to scale from day one. That's a different beast altogether. And that's what I'm working with at the moment. Then you know you're going to be getting a bunch of developers, a bunch of customers. You know, like maybe the business people you're working with have already validated the idea. They already have a queue of clients waiting to join. Then you have to design from day one with the idea of multiple teams, multiple customers, multi-tenant installations, stuff like this.
Yeah.
That's a different beast altogether.
Yeah, I would break this down as the 0 to 1 problem. and the one-to-many problem. So 0 to 1 is like you have no customers, you have nothing, and you have to create something that at least one customer buys. Right? That's the 0 to 1. That's a challenge in itself, and it requires different skills and different techniques within the company. Probably some rapid prototyping, just put something together very quickly that you can release with very low cost. You don't need a pipeline. It's a one-time thing. You just deploy whichever way you want. You run it whichever way you want. It can run on your own server or on a cloud. It doesn't matter. Just get it out is the point, is the name of the game. And then from the one to many, that's where you have to start scaling, or you have to repeat the pattern. So you don't want to waste energy, and you don't want to repeat the same work items all over again, because that's just waste of human life. That's when you have to think about automation and how to release and what are the commonalities between all the releases and all the customers, what they need, what seems to be an emerging pattern that you can automate. So it's a whole different, it requires a different mindset. There are people who are very, very good at doing the 0 to 1, very creative people, experienced in putting something together, but typically those are not the same people who can run a company efficiently, or run a software system efficiently, or think about security, or all of those extra layers that you have to put around the product to make it production ready is virtually non-existent typically in the first iteration, in the 0 to 1 situation. So it requires different people, different technologies. And that's probably when you switch from the one to the many customers, one to many services, or whatever you want to call it. That's where you have to start taking it a bit more seriously, because every decision you make will count. And also technology choices at that point will carry over for years.
Mm-hmm.
When you do the first prototype, you can pretty much do it in whatever, because you're just proving that you can sell the service. You're not proving that it's, or you're not focusing on having a mature technology. But when you're in the growth phase, it's much better to get people who are experienced and probably a bit more senior, typically, who can set up your company for the future, because they have seen this before. They're not discovering what happens if I have to release 100 times a day. They have seen that, they have done that. So they know what mistakes to avoid. This is how I would, from a 10,000 foot view, describe the situation.
It's a very good description of the two different situations. I'm currently involved in both, which is kind of a bit jarring at times. But then now I think about it, and the one that's supposed to be like the vibe codey, more enthusiastic, hacky one, they're doing exactly the same, the one to many problem, but they're approaching it as if it's a prototype, which isn't going to work. Now you've mentioned it, I'm thinking about it more. But the other startup, they're doing, I think, what is the one to many problem very well. They've hired a bunch of senior people. They give them autonomy and trust around a certain area, and they say build it with 6 months in the future in mind, with 20 developers, 100 clients. And so that changes your mindset completely. So we're building, from day one, we're building microservices. We're deploying to Kubernetes, which I'm not a big fan of, but like that's the way it is. We have multiple environments. We're going to set up development pipelines, the proper pipelines. We're going to have 4 eyes on so we have to, for example, target SOC 2 and ISO 27001, which means we have to do the prod separability. So like the traceability of production deploys and stuff like that. We're going to have SNCC as part of the deployment pipeline. I think they have code quality checking as well now as part of it. So we have to do a lot of stuff like this. And then also like setting up all the AWS and cloud infrastructure in the right way, because we're already having to do CIS foundational scans on the AWS infrastructure to make sure that that's viable. It passes all the checks so that they can be partners and stuff like this. Then I think, if I was to put it this way, like if you're in a startup like that, it needs to be well funded, because you have to hire senior people to be able to do it. But the issue with having just senior people is there's there can be a bit of clashing personalities. I'm not seeing it in my current place, but like I've seen it in the past where there can be some stubbornness. So then there's hiring you have to take into account. You have to hire the right people.
You mentioned these layers that you have to add. What most early startups don't think about is exactly this. How do I ensure that the release software has high quality or a good enough quality so one new feature won't break the other one? So you need more serious testing, probably integration testing. You need security scan. Am I introducing a serious security vulnerability now that could be exploited and just bankrupt the company overnight? You have to think about the compliance things. Like if you're in the financial industry, you have to you will have local regulations that you have to follow. If you're in Europe, you have GDPR. If your customers require it, you might need to do. You might be forced to do ISO 27001 or SOC 2, or you have to be HIPAA compliant. So there's a lot of extra work coming in that in the end will not increase your revenue directly. It's just a table stakes, this like a feature to operate a business or be able to get bigger customers, because they will actually require you to provide these reports. They want to see your vulnerability and general security posture. They want to make sure that you're certified, and all these will add on top of the features that you want to do because you're the best company ever and you want to do the nicest features to your customers. And everything else we just listed is extra things like the release, the maintaining your infrastructure. Let's say if you're in AWS, maintaining your AWS infrastructure, constant software updates, constant changes to everything. Suddenly you have such a burden on you that you have to deal with that can be overwhelming if you're working with a more junior team who has never seen this before, and they just figure out as they go, and they might make decisions that you will pay dearly for later, either because you're not non-compliant and it comes out maybe you're gonna be breached by attackers, and then that's a disastrous event, and your whole company suddenly is worth zero because you have to pay rent somewhere that is more than your company's worth. So I think like it requires a bit more mature approach. But as you said, like if you have funding, you have a runway that you know is lasting for a year, and you do know that you have the financial means to buy services that do most of these things, that gives you a huge advantage.
I think probably the biggest in that scenario, probably the biggest mistake you can make is the not built here syndrome. Like not buying services that do these things for you.
Yes.
That is absolutely the most crucial thing, I would say. That and hiring good people.
Yeah. So if you hire engineers, they're going to engineer. That's how it is. If you give them a direction to focus on, they're going to work on that. If you don't give them clear instructions, what you expect from them, they're going to just engineer what they think is best. And that's where you end up having custom internal solutions that you could have bought for $5 per month, right? Yep. And then it's worse than just, we wasted the time and money of the engineer. We also wasted the opportunity for those very same engineers to work on something that differentiates you on the market, because fixing vulnerabilities will not differentiate you on the market. So if you can get tooling that helps you doing these things, you should take it. Like everything that is not core business should be bought. Yeah, but if you don't have money, if you're a technical founder and you have the skills, but you don't have money, and sometimes you just don't have a choice, right?
So like, I'm thinking use GitHub Actions, use Snyk, use a cloud provider, use a logging and metrics provider. I'm thinking more from the infrastructure side of this. Like if you have to run Kubernetes, use EKS auto mode so that you don't have to manage any of the nodes or anything. Try and keep it simple. Buy whatever you can to increase velocity, and try and, as an engineer at one of these companies, try and think that your time is, when you're in a well-funded startup, your time is most valuable spent on either unblocking people who are creating the initial value, or creating the initial value yourself, depending on what type of engineer you are. Your time is not well spent creating, I don't know, an email server that sends emails. Just use SES or something like that. for me.
So, okay, let me ask you this. I have an idea that involves creating a website that people can interact with, and it saves data and some management software online. What would you recommend as a starting stack? I don't have customers yet. It's just an idea. I want to throw it out and see if I have traction. I will buy some ads to market it after it's done. What would you pick as a tech stack?
I would go to Lovable. I would say, this is what I want. I want to be able to people to log in. I want people to be able to buy. They have all integrations. I would, if possible, I would avoid Lovable Cloud because I've heard horror stories about that. I don't know how, I haven't used it recently. So maybe I would try and use Replit instead. Something that builds everything for me so that I have the product as quick as possible.
To
right?
build and host.
Builds and hosts, yes. And then I would just pay the money. Like, because $50 a day to develop your product is way cheaper than hiring a developer to get it done for you. And if you're not making any money, if you have no name, it doesn't matter if you get hacked so much. I mean, I would still be like uber focused on getting that first version out. So whatever tool I could use to get that done as quickly as possible, I would do. That's me now. At some point, maybe if I started getting actual users on the platform, I would look at pulling it out and maybe hosting it myself so that I have more control over it. But that's because I'm a technical expert and I know how these things work and I want to make sure that it all works fine.
That implies that whatever tool you pick, you should have the capability of going rogue, so taking out your code and your data, eject from that platform and be able to run it yourself once you can afford to have your own team.
That's why I hesitated a bit about Lovable, because I've heard some horror stories. I don't know how real they are. Maybe I'm spreading false information here, but I've heard about Lovable Cloud and you're not able to access your data, for example. That's a big no bueno for me.
Yeah.
Because the data at the end of the day is the most important thing. Once you have the feature set out and the paying customers, then you have to own your own data. Otherwise, it could just disappear and no one would be happy. And you can't sell it if you have access because that's another revenue stream. But back to your question. Say I have a very simple idea. It's a website that has a sign up and then users can pay for something and they get something. I would use something like Replit, hack it together really quickly, verify the idea. If the idea works, I would pull it out and host it myself. Probably Next.js React on some sort of serverless platform. Versal is fine. And then some sort of database provider, MongoDB Atlas or some Postgres, maybe Supabase. Supabase is good because you can have a really nice auth flow with all the auth providers and stuff very easily with Supabase. So next, Versal with Supabase. That's my answer. And
then, now I validated the idea and I can afford, I got funding based on the initial success of the product. I got funding for, let's say, a runway of 1.5 years with maybe 3 developers. How does that change your approach to the problem? And we expect, obviously, every investor expects a hockey stick figure when it comes to revenues and customer acquisition. So you have a reasonable assumption that your user base will grow exponentially, or let's say tenfolds over the 1.5 years.
Good question. My first thought is I would still stay with what I have, because if I'm on Supabase and Versal, they both scale. But my second thought there was I need to check the unit economics. I need to make sure that the user pays more than the hosting, because the Versal fees can get very expensive very quickly. I'm sure Supabase can as well. All of these serverless magic platforms can get very expensive very quickly. It's the same with AWS, but it's more of an abstract thing. So I'd have to check the unit economics. If I think I'm going to make a load of money, if like each user cost, I get like 1,000 times more than the platform cost, even with Versal scaling fees and stuff, I would stick with it with 3 engineers and I would set up some sort of dev environment. It would be probably, and this is just off the top of my head, it would be GitHub integration with Versal and Supabase. So when you push to main, it deploys to a dev Versal and a dev Supabase, right? And then I would have a prod Versal and Supabase that I manually promote to. And then I would probably also look at logging and metrics so that I can start getting information. I would make sure I have Google Analytics or something like that installed so that I get user information, proper like analytics of how usage patterns on the website. And I don't know, I would then you start running into things like communication. Like if the team is remote, I would always set up a Slack. Doesn't matter if they're remote or not. But if you're mostly remote, Slack is a must. And then developing a culture of having to do like daily stand-up check-ins, making sure that the dev channel is constantly talking, everyone's saying. Then I would have a discussion with them whether or not I would put brands protection rules on GitHub to have one PR approval so that there's always eyes on things. I don't know with 3 people if it's worth it or not. But anyway, we're getting into like little implementation details there. But like if I was 3 devs and the unit economics were fine, and this is something that probably most startup engineers wouldn't think about, is like, is it going to cost me more to host it on this platform than I will make? Do those maths early. If you're still going to make loads of money, stick with the simplest. That's my answer.
It's very common for startups to go between different cycles of, we have to expand rapidly because let's say your idea is replicable. So somebody else could build the same. So you have to gain a lot of market, but you have money. So then the instruction typically from the C-level is, let's gain as big of a market as humanly possible. Just throw money at the problem. So don't waste your time on optimizing anything. Just increase, new markets, new countries, new features, and just to capture the potential addressable market as much as you can, no matter the cost. Because if you're hesitant or you're moving too slow, then you might lose the market, and then there's no growth potential. And then that's the phase, I would say, when we accumulate the most amount of technical debt and we avoid the decisions that you just mentioned, like to what's unit economics, because it's not going to be in focus. And by the end, when you're finished, it could be that you have like half of the market, but you're operating at a loss. So the more customers you have, the more money you lose. And then typically that's when the cycle changes into, let's do cost optimizations and let's look at the technologies. Let's remove the technical debt. Let's see if we could do it on our own. Should we run our own CDN or should we buy the CDN? These decisions become commonplace, and you have to have a good team in place who's conscious. So I think what I'm trying to say here is it's okay to do this, to grow rapidly and just leave behind a lot of technical debt, as long as you're consciously doing it. I think the risk rises when it's not conscious. So it's just an artifact of what you're doing, but you're not aware of it, because fixing these issues later can be really, really difficult. We have participated in or led actually multiple projects that took years. Getting rid of an old system that you had can take like 5 years in a bigger company.
And like retraining the whole engineering organization, thinking in a different way. It's such a massive culture shift.
Yeah, exactly. Yeah, so I think that's the value of having someone in an early startup who has done it before, is to avoid these mistakes or consciously making the right decisions so it's easier to correct the mistakes. For instance, like you can have a tech debt registry, like where you just write down, hey, this is a problem. We know about it. We made a conscious decision to accept this risk. We know we have to come back later and fix it, but right now we're going to ignore it for the sake of not going out of business, right? Because let's say like you have to increase your revenues.
I remember talking to a successful founder about this, and he said it was a balance between tech debt and features, and you want to keep it just off the point where the whole company collapses and push until you sell, and then the buyer can deal with the tech debt.
Yeah, that's what. Yeah, actually, it's not far from the reality of every company. You just if you can't afford to fix everything, you just don't, because nobody will care that you had the perfect code base and zero vulnerabilities if you make zero money. Right? So it's like, who cares if a company goes bankrupt? Nothing mattered in the end. It is always a balance, but there can be. So obviously, if startup makes the right decisions early, and by right it means right is always relative, right? Like given the certain circumstances and the foreseeable challenges that are coming, you can make the right and the wrong decision. And if you make the wrong decision, it will be prohibitively expensive to fix, is what I'm trying to say. Typically, these are vendor lock-ins, or you pick a language that only 10 people in the country can write code in.
Yeah.
So I would say, like, for most of these startups that we see, making a difference in the feature set is what matters. It's not like, don't try to be unique in, we're using this exotic language because it's from a computer science perspective, that's the most complete and perfect. Nobody cares. What are you selling? What is your product? That's what matters. Nobody sees behind the scenes. So I would encourage everyone to use boring languages, use boring libraries, something that's mainstream you can hire for overnight. You will be way better off than being cool and then not just sitting there with your perfect product that you can't sell because you can't hire more people to create the features that are needed.
I didn't even realize that, like, what I'd done when you asked me that question is think about tech debt in the future. And like, because it just instantly came to me, right? Okay, do it on JavaScript, because pretty much everyone knows JavaScript. You can hire. I used to joke that you could throw a stone in Stockholm and hit a JavaScript dev. If it works with scaling on the serverless stuff, just do that, focus on features. It's not really tech debt if you're going to make money, if you do the unit economics early. Because if you do the unit economics early and you're still really small and you have a really small code base, you can pivot to something that will be profitable in the longer term.
Yeah, and just knowing, like, just the knowledge that you know what the cost of a single user is gives you the power to know what level you have to reach. Because then you know exactly, like, if I will have 10,000 users, I become profitable. So you can confidently say that sometime we will be profitable. You know exactly, if we get 15,000 users or 10,000 users or 5,000 users, we will be profitable. So that's a huge advantage over companies who just do things and see what happens, right? Being aware of it. Because then, in my experience, if you expose this information to every employee, you give them the chance to make the right decision. Because then when they say, like, should I use EKS or should I use AWS Lambda? Then maybe they think about, okay, let's calculate what would be the cost on one or the other, and then pick the right technology. So it trickles down into the micro decisions that engineers make on a daily basis, and management tends to forget how important this is. And that's why I come back always to give engineers a purpose and a goal, because otherwise they're going to just engineer for themselves. And that's when you end up with super expensive systems.
Autonomy and trust. So you say, this is the goal of the company. We want to be profitable. Your service needs to be cost effective. Do it. And then you'll get really happy engineers because they like being trusted with things.
Yeah, 100%. I've seen horror stories in this.
Yeah.
Like when engineers pick the right technology from the computer science perspective, but it was so expensive that it almost bankrupted the whole company because nobody challenged them on this decision. And once the system is in production, changing that is really difficult.
Temporary is forever. Yeah. But let's switch over to, and I can ask you the same question. If you're okay, you have a new company that you're starting, but your co-founder is very influential in the industry that you're entering, right? You've already lined up a bunch of investors. You have 2-year runway for 20 engineers, and you have 20 customers lined up already. How would you start? You have nothing. You have an idea. You know what you want to deliver. How would you go from 0 to 20 from nothing?
So in terms of tech or in organization?
Both. Start with tech.
I would start with organization.
Okay, start with whichever you want.
Because, and this is true for the biggest companies actually, you break down the problem into sub-problems. So we typically call these domains, but you can call them whatever, groups or organizational units. Typically, there's a customer-facing one, then there's a back-office related domain like billing or reporting or data analytics, and then there's the critical systems are typically organized into one domain. That would be, in finance, it would be a transaction processing system or order management system or whatever is business critical. That's how I would start. Then the next step would be to define the contracts between these domains. These are typically APIs. So I provide, let's say I'm the customer management domain that stores all the customer data. Then what do I have to provide to the other domains or externally? And that would be like APIs, events, schemas, a contract with the data team. How do we move the data there? So we're technically just creating these independent units, organizational units that can work autonomously, but work on a contract with the other domains, as in a technical contract. That gives you the opportunity to start working internally on the domain without having to rely on the other domains all the time, and therefore you're not blocking each other. Once the contract is in place, then you know what to follow. So you know what the expectations are, and of course we can iterate over this, but then you can work full speed within the domain. So it's a typical divide and conquer strategy. Then the more people you are, the more the more necessitates this type of breakdown of the organization, and this can be scaled. And then of course, like within the domain, you can have multiple teams that focus on sub problems on, let's say, the billing. Like one works on sourcing the information that you need for the billing, the other team works on generating the invoice, and then the third one organizes the payments or the payment requests. So it's if you organize this way, you can still have a very flat organizational structure, which is beneficial even in a startup, but you can also grow quite big. We have seen companies with several thousand engineers working in this manner, and it works quite well. And it also unlocks the potential of the engineers, because you're not waiting for the top level to hand down the instruction what to do. Each team and each domain has to figures it out themselves.
I agree with you completely on the organizational side. You want autonomous blobs with clearly defined contracts and ownership areas.
Yes, and the reason why I wanted to start with the organizational breakdown is because the tech should follow that. Because once you have the contract set, then you know, okay, I have to build an API. Like, what technology should we use? Then it's obvious if you have 5 APIs cross-domain between different domains, you probably want to have a standard for it, right? So that's when you start introducing these layers of professionalism, shall we say, where you apply the same techniques. It reduces duplicate efforts, because if you use the same date format, then everybody knows if I create an API, this is the date format we're using. I don't have to think about it. There will be libraries. If I create a library, others can use the library, and so forth. We typically standardize on messaging technologies if we choose to use event-driven architectures, and then we say, like, okay, messages should look like this. They should have a metadata section. They should have a data section. Why is that important? Because then the data and analytics team can always rely on, regardless who emits the events, like they can see, like they can apply the same processes, same analytics to understand what's happening company-wide. And these are the things that make a company efficient and good versus a chaotic hellhole that nobody wants to work in. If every team does their own technology and own language and own style of API, then it's going to be very high mental burden to start using each API, and you have to repeat the work unnecessarily just because somebody uses a different date format or something. So that's why I think it's important to have good organizational structure and then be good team player, really. And what that entails is these type of agreements. These don't need to be top down standards. Like, it's not like the CTO sits there and this is how we're going to do it. It should be, hey, we agree between the domains as peers, and then we just follow because we want to be good team players.
I would, if you're going up scaling very quickly, I would say standards are needed, because you're going to have someone like me who's going to be flailing around in the dark trying to make everyone else faster. And if they have to support a bunch of different stuff, it's going to make it way harder. Whereas if you decide on, say, 2 languages and 1 deployment target, makes life way easier. And then that is, again, it's about maximizing efficiency in a way that scales.
Yeah. Totally. And why are we talking about this? Because these sound like big enterprise problems. But if you, early in your startup phase, you think about these things, then you can leapfrog other companies who make the mistakes in the beginning, and then they spend years on rewriting software, deprecating the monoliths. All these mistakes that they make can be avoided. So then suddenly you can literally be like 1 year ahead of a company that started 5 years ago. Because you just started later and you're not making the mistakes, while they're still working on technical that you can you can leapfrog them. So you can. That's why small startups who are conscious about these things can easily run around big companies who've been around for decades in terms of quality and feature set, and everybody switches to them. And the old ones are just, everybody just looks at the old ones as dinosaurs, and they will go extinct.
If I had lots of money, this is what I would do probably. Pick these old monolith companies, start a new company that's well engineered from the start, and then just take all of their money. You just make so much money doing it, I'm sure. But you need a lot of money to start that up.
Yeah, definitely. So it's not easy to fight against the big ones. I'm not saying that, but from a technical perspective, you can outperform them very easily.
But I think you can fight them well, easily. What I mean is, it's not like you can start in a basement and develop. You can. It takes a lot of effort. But if you say you have $1 million or 2 years runway with 20 devs, if you make the right decisions initially, this is basically what you're saying. If you make the right decisions initially and engineer well, you will overtake the entrenched players who've done it wrong.
Yes.
100%.
And this is where I would recommend, don't buy the cheapest people.
No.
Because the cheapest people will produce the most expensive system that you've ever seen, because they simply don't have the experience. We're talking about juniors, fresh out of university. They don't know how to build the right systems.
I even argue some mid-level people as well, because they don't think business-wise. Like founding engineers, a well-funded startup should be senior enough to understand the business issues as well.
Just to illustrate this, how this happens on the infrastructure side, we have seen several companies who, back before the cloud times, they had their own data centers. And even data centers could be built in a nice way and in a terrible way. Like you probably have seen pictures on the internet where the cables go everywhere and it's like unmaintainable. And if you remove one cable, everything breaks. So there could be differences between the data center setups. But then most companies, when the cloud providers came along, they started moving into the cloud. And we have helped countless companies who have done this mistake. What did they do? They just took the existing engineers who were very professional in the data center, and they said, here are cloud resources, use them. What did they do? They just built another data center in the cloud. So they didn't.
But it's like they're paying to build a data center in a data center.
Technically it is. And then what do I mean by that? Like, so they didn't do separation of the payloads. Everything went into the same account. We're still running EC2 instances instead of using the native cloud technologies like Lambdas, or using Kubernetes clusters or AppSync or whatever, App Runner. They just copied one-on-one what they had in the data center into the cloud. And that creates security issues because the blast radius is massive, just like in a data center. So they just carried over the problem. So we helped companies deprecating data centers in favor of cloud. Takes years. And then they end up with a more expensive data center generally in the cloud. That's another typical work we do, is to move the data center looking cloud infrastructure into a properly aligned technology. And I'd like to circle back to what we talked about earlier, like the organizational structure. We typically create the infrastructure to the shape of the organization as well. We have separated team accounts and team or at least domain accounts, so the issues and attacks don't propagate between the accounts, the AWS accounts, let's say. So it's important to have this foresight day one, because with minimum cost overhead, you can prevent a lot of very expensive migrations. And these migrations take years for many teams. So if you calculate with a team's typical labor cost and multiply it with years, you're literally talking millions of dollars for zero business value. Because there is business value, but there's no direct business value. So you won't have better features. The customers might not see any change that you wasted that money. Yes, you will have better security posture. You will be able to move faster, develop faster, release more independently, different areas of the software. So it has a lot of benefits, but it's an awful lot of money. I mean, we make a good living out of it, but if you can prevent it, listen to us, just don't do it. Pay upfront a little bit to understand what not to do.
It's technical debt, but a different type of technical debt. It's when you're hyperscaling or scaling very fast, you're, instead of building up technical debt, not migrating from Versal to containers as soon enough, you're building up technical debt in an organizational fashion by not making the right decisions early. You're building into a organization that has blockers, and that costs stupid amount of money. Like, you end up with Jira ping pong and stuff like this because you haven't defined the ownership areas properly. And it's the same as what you were saying with the cost to people times X amount. So there's 3 phases for a startup, I see. There's the initial one where you're fresh and you don't have any funding. Cost of technology is quite high, right? So the founders usually put their time in for free. The cost of hosting and whatnot is high compared to your income, which is nothing. Then you have the second phase where the cost of people is more expensive than the cost of technology. That's sort of like the small to medium size area, because you have a lot of people, you're deploying to the cloud costs aren't that high if you've done it properly, or even if you haven't done it properly, it's not that high because you don't have that much traffic. Then when you get really big, you go back to the point where the cost of compute and technology is higher than the cost of people. Most fast scaling startups sit in the middle where people are more expensive than the cloud. So you should organize in a way that doesn't waste any engineering time. And I've seen horrible examples of this, like people having to wait days and days to get an answer on a ticket for deploying something because you decided the best way to implement ISO was to have a team that deploys for you. That's bad. You should reevaluate. Another one that really annoys me is engineers when you're in this middle phase, engineers are by far your most expensive resource, and you decide to give these expensive people a really bad laptop. That drives me insane because you're slowing them down. It costs, and these are hidden costs, and we'll probably talk about hidden costs a lot in this podcast in general, but like just something as obvious as if you want people to do good work, give them good tools. And that's just one of my pet peeves. But I think in terms of like a successful company, they'll spend most of their life cycle, unless they're like a crazy unicorn, they'll spend most of their life cycle in that middle phase where people are more expensive than the cost of technology.
Even at like higher, like let's say you have a 300 headcount organization, your biggest cost definitely will be the people. Even if you're in the SaaS tech business, it will probably be like 80% of your cost. Tech should be below 10%, I would say.
But then at some point, you're going to be a Google or a Facebook. Then you have to build your own data centers and you have to do all of this stuff. Then all of a sudden it becomes more expensive for compute. But for the vast majority of companies, people are most expensive. So when you're designing your scalable solution, that's why it's a good idea that you started with organization first, because you want to design the processes in a way that blocks them as little as possible. And we've had to go in and totally change whole development organizations because they had the stupidest blocking policies. And it's because people just didn't think that engineer time not spent working on productive and or profitable features for the company, pivots, new markets, whatever, it was better to have them wait on a Jira ticket than do that work. And I mean, when you point it out to them, they go, oh, but like it's for some reason, these hidden costs are really sneaky. And you want to make the decisions early that try and minimize those. I think Klarna were very good because they said, don't waste anyone's time because you're going to be costing us a lot of money.
One of the key principles that we like to apply in these teams is unblock others first. As a general rule of thumb, like if you have to choose between doing something within your domain or unblocking another domain, pick a second first. That was weirdly formulated.
I agree.
Unblock
like unblock first. Yeah. And then have a think about why they were blocked and try and stop it from happening again. Yeah. And if you have that kind of constant evolving culture towards less and less blockers, you'll get faster and faster over time. And hopefully, well, you'll at some point you'll reach peak speed, but then you'll stay at peak speed instead of introducing more and more blockers. Because someone will say, oh, why don't we, have a Jira ticket for this? And you go, is that going to block them? Yes. Well, then we won't do it. You should have that in the forefront. Don't design any blocking processes.
And also, so this can collide, this mentality of having streamlined teams that don't block each other, meaning, let's say, like we don't do the Jira ping pong you mentioned, like to release something, I have to file a Jira ticket to this other team and they have to pick it up and they do something and then I do something. I usually have the process and I count how many team handovers need to happen for a business function to be fulfilled. And if there's more than 0, I look into it because that means we didn't organize ourselves the right way where we can deliver value independently. And another important aspect of this is we have to change our thinking on the tech side as well, how we architect data structures, how we architect the bigger system, because we have to take on extra complexity on the tech side. So we unblock or we do not block each other. So let's say denormalize the database, like so each domain would have its own data store of the customer. Or let's say the customer management system just emits events that everybody can store and project the data into their own needs. I only need the customer name. The other one only needs the ID or the email address. Then they can keep a record of the customers themselves. So they are not blocked by the central team that needs to do something to fulfill their business functions. Maybe it's a clumsy example, but the point is that we have to align the architecture and the way of thinking on the tech side to unblock the people, because the people are the most expensive resources. So it's not the complexity. When I think about complexity of these architectures and organizations, I don't think about the absolute complexity, how many components we have and how many connections between the components. I think about what is the complexity of a change. If I need to release a new feature in like the order management system, how many teams have to be involved? How many domains have to be involved? Do we need to cross domain boundaries? And if the answer is like, we can just do it ourselves, that's the right technical choice. And it comes at a cost, technical cost as well. Namely, you might need to store data twice. You might have to process data twice or even more times. But in the end, the technical cost at most companies is much lower than the human cost. Therefore, I rather spend money on the tech if it unblocks time for the humans.
It also has the added benefit of making your system more reliable. And because if everything's, independent and decentralized, you don't have any single points of failures or anything like that either.
Yeah, correct. Maybe we went up into the mid-size companies, so less of the startup.
But I think like it's the same principles, I think, is what we're trying to get at here. Is like if you're starting with nothing and you're going to have a lot of customers and a lot of developers, you might as well design a mid-size company from the go. Well, you can reduce some of the processes and stuff, make it a lot easier, but with the goal in mind, at some point, all of these things will be in line.
Yeah, and just to reiterate, like if you're running on fumes, you don't have any money, you can't afford most of these techniques we're describing, because you would go out of business before you even started. So this applies when you got funding and you try to set yourself up for success and growth. That's what it is. And show me a company that doesn't want to do that. Right? Oh no, we're not going to grow. Like everybody wants to grow. So that's why I think it can be generally applied to early startups as well, not from the 0 to 1 where you just do a minimum viable product or a proof of concept, but everything after that, once you start building a team, start building an architecture system, like a bigger system, you have to think about these things.
Something that popped into my head is the tricky thing with building that kind of going from one to many from nothing, if that makes sense. Do you know what I mean? Like you start the company thinking, I already have one, I'm going to go to many. The blocker, the issue that I see working with the company I'm working with now is hiring issues. So they want to develop this really balanced, big system, microservices, for build pipelines, all that sort of stuff, right? Proper documentation, everything. But they can't hire enough people to implement it fast enough while also hitting the milestones of releasing the features on time. So it's a bit of a juggling act there as well, which is a bit tricky. I don't know how to solve that. Just work harder, maybe.
But you always find people who are willing to sacrifice salary for exchange of a share in the company. So I think you can get good people early as well, because there are many people.
Get freelancers and consultants in as well. Don't be scared of them.
Yeah, just use them as a resource.
Yeah, like that's what I do.
It's very interesting because in certain cultures, being a contractor or a consultant means like you're the lowest form of existence, Or that's what
Yeah.
they how they
Yeah,
perceive it. So I've seen that typically in the US working environment. But
I've seen it in Sweden as well, by the way.
in reality, what it is, you're buying expertise that you don't have in the company, so you better use it well. And
Mm-hmm.
it's you can just hire consultants and let them just work or be muscles, but I think that's not the way to use. So these are typically the temporary power, like temporary force. If your hiring pipeline isn't going as well, and then you just complement the team. But if you would really want to make changes in the way you do things, you can hire consultants who help you get over the road bumps.
Yep.
Yeah, we're typically working on that level, not on the we just need another junior
I don't
developer.
like being the hired muscle. I like to help.
Yeah.
Like with this discussion we're having right now, having
Yeah.
this discussion with founders is really interesting. You say,
Yes.
okay, explain to me your plan, and then you point out the points where they need to think about certain things. I do enjoy occasionally going into the trenches and setting everything up because it keeps you fresh, right?
Mhm.
You should probably have a CTO who's invested, is an employee, but a senior engineer or architect or process engineer, someone who understands the business and understands how to scale an engineering org pretty early on. If you have a lot of money, then get someone like that in, definitely.
Mm-hmm. So we covered various size companies now, from organizational and tech side. Okay, so to summarize, what are the important takeaways from this discussion? Toby, what would you say?
To summarize, there's two groups. We see them as two groups-ish, 0 to 1. So you have nothing and you want to get to something to validate the idea. Use whatever you can to get the product out as fast as you can. If you then run into this idea is actually great and a lot of people want to buy it, maybe do the unit economics early on and see if your current way of deploying and running the system can handle a lot of people. If you want to make the trade where you stick on your expensive platform that's easy to use in order to capture the market, and then you're willing to trade that for tech debt later, then do that. If not, maybe pivot a little bit earlier and build a more profitable, more cost-effective system initially. That's one side. That's the 0 to 0 and then onwards. For what I think more complicated and more difficult, one to many from day one, you want to organize properly, avoid blockers, and develop a organizational structure and ownership structure and autonomy within the system, well, the teams, that avoids blockers at all costs. Introduce standards pretty early, at least some sort of consensus around standards. Try and use boring languages, well-known technologies that aren't going to bite you in the ass. Buy everything that isn't core business. So deployment tooling, security scanning, logging and metrics, everything. Don't build anything internally that isn't core business, and give your engineers good equipment. Don't block them at all. And make sure communication is really good initially as well. I don't know what else would you say for that mid-size.
Yeah, I think this is a very good summary. Generally, like what you mentioned, the build versus buy. Yeah, buy on the core business. Enable the developers. They are your most valuable assets. Give them autonomy and check on them.
Trust but verify.
Yeah, exactly. Trust but verify. And try to learn from mistakes others make early on. As you said.
Yep. Use
common technology, like the most popular languages, the most popular libraries. Don't innovate on the infra side. Innovate in your product is the advice I would give. Very good summary to me.
Thank you. Okay, I guess that's it then. Thank you everyone for listening to the podcast.
Thank you, Toby.
And thank you, Krisztian.
Puss puss.
Bye-bye, puss puss. Thank you for listening to the Tech League podcast.